Hi, my name is Richard Shi. I'm part of the S.O.L.A.R squad, and I'm here today to talk about the exact mechanism of the dye-sensitized solar cell and the results from an experiment that we performed at Farmingdale State University. So right here, we have a diagram of the dye-sensitized solar cell. Essentially, it's really composed of four main components. Now, the first component is the top conductive glass plate coated with a semiconductor titanium dioxide as shown above. Next are many dye molecules or dye solution which is adsorbed onto the semiconductor surface. Next is an electrolyte solution which is inherently found around this area, and lastly is a bottom conductive glass plate which is coated with a carbon layer. So what actually happens is that the photons from the sun actually excite the dielectrons. Now once these dielectrons are excited, they then move on to the conduction band of the semiconductor titanium dioxide as located here. From the semiconductor, these electrons then move on to the conductive glass plate, and then preferably to a load, say like a light bulb for instance. From this light bulb, it then moves on back to the solar cell, but this time to the bottom conductive glass plate with the carbon layer. From this carbon layer, these electrons essentially, with the help of the electrolyte solution, move back to its dye molecules as they once originally were. Here are our results of the experiment we performed. Again, here is our control group and here is our experimental group. The control group consists of three dye-sensitized solar cells. These cells were not tampered with in any way or form. They are essentially just normal cells. On the bottom are dye-sensitized solar cells, except for the fact they are equipped with a zinc oxide UV filter which is located on top of the cell. So as you can see here, we managed to measure power output over time of 40 minutes. As you can see for the control group, the power output over time was really unstable. I think there was a power output decrease of 87% in a span of 40 minutes. This is definitely not good for the dye-sensitized solar cell. Once we managed to include a UV filter, the results seem to look very good. As you can see here, the results are very consistent. I mean, there was barely any sort of change in the durability of power output. So, by managing to increase the durability of these solar cells with a zinc oxide UV filter, we essentially get closer to the application of these cells to society. This essentially benefits me and you and everyone around the world in the future. Thank you for watching this video. I hope you learned something from this. If you have any questions, leave it in the comment sections below. Thank you again and have a good day.